Okay, so let's talk about the topic first. But topic doesn't change as a overall what we're talking about. In that, what we talk about matters. So today we will be talking about uh, something which or a topic which is further or extended version of that mm, thought experiment. So we all know about Schrodinger's thought experiment, in which he killed his poor cat. Ah, so Schrodinger's cat, and there are many, there are different experiments, and oh no, not experiments. There are different people who like talk about the experiment differently, and until we are talking we have the content same. It doesn't matter how you put the cat in, what part do you put the cat in. So what here what I will do is that I'll use the bomb. Yes, I'm gonna put the cat in a box with a bomb, which is a 50-50 chance of exploding and not exploding. So that means this kitty cat, that's a horrible drawing. So this kitty cat is in a box with a grenade. Okay, and this bomb, it has a 50-50 chance of exploding. So that means this cat has a 50-50 chance, 50-50 chance of living and dying. Sorry, die you. Okay, so that's how it is. So it has a 50-50 chance of dying and not dying. Now, uh, what we're trying to say is uh, that we know the probability of it not dying and dying, but what makes that probability 100%? What makes our 50-50 or 50% turn into 100%? Let me guess. Yeah, it's a observation. What's that word? Observation. Sorry, I should have done that. So it's observation. Okay. What I mean by observation is we know that this bomb here, this bomb can explode and cannot explode. But what's our interpretation? How do we know it will explode and will not explode? Our 50-50 came from the condition that we're not observing it. 50-50, 50, what degree? 50-50 is on not observing. Observing. Sorry, not observing. Okay. Now, and what is that 100%? That 100% is on observing. So, what's our change? Our change is 50% to 100%. And how? Not observing to observing. Okay. So, which phenomena does this topic or does this experiment cover? Yes, the phenomena of superposition. Superposition. Now, how do I talk about superposition here? Now, look, we'll use not we will be talking about not observing. Now, not observing means dead, alive, or alive, dead. Either we get alive or dead, or alive, dead or alive, or alive or dead. And on observation, if we observe it, either it will be dead or it will not be alive. It will be alive and it will not be dead. So that's the scenario, right? Wait, is it more? Either you will die or you will not die, or you will live or you will not live. It's the same thing. Yeah. So here our key is observation. Observation is the key. So we now the Schrodinger's cat is experiment is considered that we put a cat. Apparently, he hates cat. I don't know. So he keeps a cat in the box with a bomb, or many places they have used triggered poison and whatever you want to. So, but you should make sure that it has a 50-50 chance of happening and not happening, that so that supervision in our mind can occur. So now, so what was our key point in Schrodinger's cat? The principle of superposition, right? Now let's extend this same experiment, but now let's talk about something about now. Okay, here one more thing. Yeah, even we will talk about wave function in detail in the next part, the extended version of this experiment. What is wave function? Wave function is the many probabilities of something happening from and overall possibilities. So if I didn't make it clear, sorry for that. Let me just do. I will make it clear as possible as I can. So what I mean by that is that wave function. This is what the wave function looks like. Now the wave function is something which gives us different probabilities, and again, let me clear, not observe. Okay, so we have many probabilities. These are all probabilities of cat being in all different states. We call it states, and this is the notation. Now these are all the probabilities of cat being in a certain state. Now what is the wave function here for? Wave function shows all the possible outcomes which can take place, but this this range of data will only be useful till you observe that certain system. On observation, this wave function, or the bundle of probabilities will break, and you get one single probability. Let's suppose alive. We got this state. So what is our key point here? Wave function. Because of the wave function, we have many possibilities, and on observing that wave function collapses. That's the word we use. Collapse mean it falls down, and we get a definite value. Now let's talk about the extended version of Schrodinger's cat. Extended version. I think that was way too big of an intro about Schrodinger's cat. Extended version. Extended version. Sorry. Extended version is, let's get practical. Okay, now here we have this room which is blocked from outside. No view of the inside. And inside there's an experiment being done by, let's suppose, what about anyone? Bob. Bob is doing an experiment. It's my video, so I can make names. It doesn't matter. This Bob is doing some experiment, and it has range of values. Okay, let's suppose 1,000 values. Now he gets a value. Now, in terms of superposition, what happened? He, by the way, he's doing a quantum experiment, as we in quantum mechanics superposition is there, so we have to talk about quantum mechanics. So he gets a value. Now this value is what? It's a value which was in this wave function, which could had many other values, but this value was specified in this case. So let's suppose this was the chosen, and on this, all the other values collapsed. Wave function collapsed. Now, collapse. Uh, Collapse. Sorry, collapse. Okay, now. He got a value. His wave function collapsed, and he has a result now from many. He has a possible out. He has a definite outcome now, not possible. He has a definite outcome now of all the possible outcomes there could have been. Now, what about someone who is standing outside? What about him? What would be his outcome? Will it be same? He's wondering. He has a question in his mind. Will my be the same? Be the same? That is a question which arises in his mind. Maybe he's a genius. He is a physicist as well. So, what do you or what do we physicists think about? Is it true, or is it the same, or it is not the same? Classically, we would say his value and my value is the same. As in classical physics, whether I observe something or you observe something doesn't matter. A car crashing in my eyes is the same as car crashing in your eyes if we're at the same place, of course. So, which is again locality. Locality takes place, and but in quantum mechanics, it's a world of weirdness. Many weird phenomena takes place in quantum mechanics, which makes it more intriguing, more exciting, more want to know about. So now here, what if they both are correct? That's a one possible answer which quantum mechanics gives us. Quantum mechanics gives us the linearity to choose both. That whether he observed and he got a possible outcome, and whether I, or let's put it's me now, I observed and I got a possible outcome. But my outcome is correct for me, his outcome is correct for him. One extra person comes, his outcome is correct for him. So, does wave function not depend on each other? Maybe their wave functions are different. He has his own wave function. He has his own wave function. Some extra person comes in to clarify. He has his own wave function. So here This shows that the result in quantum mechanics is observation dependent. Each observation gives a different value, which also mean in some senses says that the observation or the wave function of the one who is doing the experiment has a different wave function, and the one who is outside has a different wave function. So wave function me is not the same as wave function him, right? This does make sense. My wave function and his wave function are not the same. Maybe in this wave function, this is his, he got this one, but in my wave function I got this one. But according to us as separate, not looking, not worrying about the other person's data, we are correct. So again, does it make sense? Well, when did quantum mechanics ever make sense? Made sense. The phenomena we have experienced in quantum mechanics till now are so, of course, headache. They give headache. Even if you say you understand it, you're not actually understanding it at all. So again, is it wave function? Is this statement? Is this notation correct? This wave function and this wave function, they are not dependent on each other. They have different um, spaces. Oh yeah, that's one more interesting way to say. Um, the person who is over here has a different space, and the person over here has a different space. By different space mean, uh, according to quantum mechanics, or in terms of quantum mechanics, in between them there's nothing. We have nothing over here. It means no relation, anything, nothing is over here. We have no, their contact is not possible at all. We have isolated them so bad that they cannot talk anything. They can have no way of communication. So his result is correct, as he has no one else to no one else to compare with. He has his own, and he has no way to compare. But even if they compare, according to quantum mechanics, they both are correct, because wave function, uh, he gets a value, they're correct in their own way. Does Again, the question is, does the wave function really depend on observation? That the observation has to be in a way that if he observes, if I observe, if someone else observes, we get the same value. No, in quantum mechanics, because of the wave function has this kind of ability. It's mysterious that even if they're different, um, it doesn't matter that whether it's correct or not. In different perspectives, it's correct. Both. So outcome is both are correct. But are they? Again, the question is always there. It exclamation or question mark should be there. We don't know. It's one of the interpretations. Interpretation. What is interpretation? Interpretation is just like Copenhagen interpretation, the money world interpretation. Maybe it's true, maybe it's not true. Again, we're talking about wave function, right? So even in the Copenhagen and even in those interpretations, many world and Copenhagen, we're talking about wave function, many possible outcomes, but on measurement we get a definite outcome. Same thing is happening here, but we don't know whether he is correct or he is correct or both are correct. Maybe it is possible both are correct. It is possible both are not correct. So it's a uh, it's our point of view. Like Do we want to believe in this interpretation? Until there is a confirmed experimental, if we can do this experiment, but of course it's the extended version of Schrodinger's cat. And I think the name of this experiment is Wigner. I used my wordings, so if you have don't want like have confusion, the experiment is Wigner's friend. That in this was someone who does there's a friend of Wigner who's doing an experiment, but Wigner is standing outside. He doesn't have any for him the experiment and the person are oblivious, and he has no clue. So that's what it is about, Wigner's friend experiment. And yeah, that's it. Thank you.